Let's see. Okay. Ship in a bottle. This one looks pretty cool. Whoa. Man, that is awesome. Hang on a second. Let's see. Oh, this one looks neat. That one's really big inside there. That's got a lot of sails. I wonder how they get it in there. Let's see. Let's see. How to build a ship in a bottle. Wow, this guy's good. Dan Berg. There's got to be some kind of geometry in here, given the size of the ship. It's like scale and proportion. So interesting. I bet I could do this. Okay, let me see. Cool. I found this in my old Christmas presents from like 4 or 5 years ago. The Secret Revealed Boat in a Bottle Kit. It even says I can do it. Let's see what's inside. Wow. Look at this. That is so cool. I'm going to put a boat inside this bottle. It even comes with a cork. Wow. Tweezers. Got to be able to put those pieces inside the bottle. Whoa. Look at these sails. Look at the size of that sail. That's like a similar polygon. Cool. Man, here's the little boat. Here's the hull. Doo doo doo. Wow. That is really cool. Oh, here are the instructions. Shh. Don't tell. It's a secret. This looks pretty easy. I bet I could do this. Alright, well I'm going to try to do this. You guys, go ahead and watch this video, and let's learn about similar polygons so we can figure out what the scale factor of this is. Alright guys, welcome back. In your intro, you saw that we were talking about ships in a bottle. Well, ships in a bottle are really just having to do with similar polygons, especially the sails. Because what we're talking about is taking something that's normally really big and making it a little bit smaller, but it still has the same proportions. So the size of the sails relative to the actual boat part is still the same as if it were a big ship. Okay? And so we're going to talk about similarity today. And what we need to remember about things that are similar is that the symbol for similar is the tilde, okay, the little squiggly line which we normally put above the congruent sign. Okay, and so if we look in 1 and 2, similar means same shape. But different size. Okay, so same shape but different size. Okay? Now, 1 and 2 are the same shape. You notice the triangle, it looks the same. So what we would say is triangle 1 is similar to triangle 2. Or we could write this triangle 1 similar to, that's the tilde that we were talking about, triangle 2. Okay, they're similar because they're the same size. Or they're the same shape, but not necessarily the same size. If we look at 3 and 4, they're different shapes. Still both triangles, but they're different shapes. 3 is more like a right triangle, 4 is kind of looking like an isosceles. Okay, so we'd say triangle 1 is not similar. or triangle 4 is not similar to triangle 3. Okay? And so we could abbreviate this triangle 3 not similar to triangle 4. Okay, we put the little slash through the tilde to say that they're not similar. Okay, so if we scroll down a little bit, we've got a definition for similar polygons. Two polygons are similar polygons if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. So if we look at these two shapes here, they look to be relatively the same shape. But when we test it, when we actually look at it, we notice that A is 90 and E is 90. So angle E or angle A is congruent to angle E. Okay? And angle B is congruent to angle F. Angle C is congruent to angle G. And angle D is congruent to angle H. So, 4 congruent angles. That's key for similar polygons. You have to have congruent angles. But then the sides is a little bit different scenario. With the sides, they don't necessarily have to be congruent, but they have to be proportional. So, angles congruent, corresponding side lengths are proportional. Okay? So, if we put AD over EH, we want to test to see if that's equal to AB over EF, and we want to see if that's equal to, AB over EF, is that equal to BC over FG, and is that equal to CD over GH. Notice I kind of went around the polygon in a good fashion here. And when we test this, we see that all of them are equal to 1/2. So 5 over 10 is 1/2. 6 over 12 is 1/2. 5.4 over 10.8 is 1/2. 4 over 8 is 1/2. So, two conditions. 1. Congruent angles. Congruent angles is what I meant to say. And the second thing is proportional sides. Okay, those are the two conditions for similarity. So when we go down here to example 1, we're going to be describing similar polygons. Identify the pair of congruent angles and corresponding sides. So what I'm going to do is I'm going to describe these using what I know. Okay, so if we look at what's going on here, angle Z is congruent to angle R. Also, angle Y is congruent to angle Q. And so we have the third angles theorem in play here, and we can say that angle X is congruent to angle S. Because remember, if we have two angles that are congruent in one triangle, are congruent to two angles in another triangle, then the third angles must be congruent because they all add up to 180. So we have the three angles congruent. Three congruent angles. The second part is to test the ratio of the sides. And so if I put XY, and XY goes with SQ, XY over SQ is equal to 6 over 13.5. And so what I'm going to do is, I got confused. I think I wrote it down wrong in my notes. That would actually be 6 over 9. Got you there. Okay? Then, this is the one with 2 to the one with none. Okay? And so what I'm going to do is now I'm going to say XZ should go over SR, and that is going to be equal to 9 over 13.5. And the third set of sides that I'm going to test is going to be YZ over QR. Okay? And that's going to be 12 over 18. When I reduce these fractions, I should get the same number if they're similar. So the three angles are already congruent, and so we're going to test these sides. Well, this gives me 2/3, and this gives me 2/3. Those are the easy ones to reduce. When I end up looking, and figuring this out, you can put it into your calculator, divide 9 by 13.5, you end up with 2/3 also. So what this means is we have proportional sides. Because all the ratios of the side lengths is the same. So our two conditions are met, and so what we have is we have congruent angles, proportional sides, so we have similar triangles here. Okay? So in the second example here, I want you to try this one. Okay? So what I want you to do is identify the pairs of congruent angles and corresponding sides. So do exactly like I did up there. Alright? So you can go ahead and pause and do that one. We'll talk about it in class. When we move on down here, we're going to talk about the similarity ratio. When we talk about similarity ratio, it's the ratio of the lengths of the sides, okay, of two similar polygons. Okay, so it's a ratio of the lengths of the sides of two similar polygons. Okay, so the similarity ratio for triangle ABC to triangle DEF is, and we'd have 3 to 6, which is equal to 1/2. Okay? If we did triangle DEF to triangle ABC, it would be 6 to 3 or 2 to 1. Okay? So you can go either way with these, but you just need to remember that you're always using one set of sides to the other set of sides. Okay? In example 2, we're going to actually identify similar polygons. So we're going to decide whether they're similar. So in deciding whether they're similar, we need to decide two things. 1, congruent angles, question mark, and 2 is proportional sides. And I'm putting question marks by these because that's what we're testing. We are testing to see if these two conditions are true. And so here's what we're going to do. So we are going to identify congruent angles. Well, what I'm going to tell you is they are both rectangles. They're both rectangles, and I'm telling you that. It gave us this in the problem, okay? And so, number 1, we're asking, are there congruent angles? Well, the answer would have to be yes. They're all 90 degrees because the definition of a rectangle is rectangle, right angle. So all the angles are right angles. And so we have this here. So all of the angles are right angles. So that means they all must be congruent. Not only are they congruent to every other one, but corresponding angles have to be congruent. Okay? Number 2, proportional sides. That's our second question. Well, we need to look at what things go together. So obviously we have this 4 and this 6 here. So what we're going to do is we are going to put PQ over TU. Okay? PQ over TU is 12 over 16. Well, this is equal to 3/4. So in order for these to be similar, the ratio of these smaller sides needs to be 3/4. So I'm going to put PS over TW, and I find that this is equal to 4/6, which is 2/3. Let's compare 3/4 and 2/3. They're not the same. So, no. These are not similar. Okay? They're not similar because the corresponding sides are not proportional. Okay? And so, let's move down and work on example B. Alright, in example B, we're going to do the same thing. We're going to test to see if these polygons are similar. So, the first question that we need to ask is congruent angles. And the second question is proportional sides. Okay, and so let's test number 1 first. Well, angle A is congruent to angle D, and angle B is congruent to angle E. And so that means that angle C must be congruent to angle F by the third angles theorem. Okay, so we have 3 congruent angles. Let's test the sides. So that means that AB goes with ED because it's between the first and second angle, so the 1 and 2 tick marks, so that's going to go here. And so that's going to be 20/15, which is 4/3. Okay? And then we're going to test another one, so we'll go BC over EF, which is going to be equal to 24/18, which is going to give us 4/3. So far, these 2 sets of sides are proportional. And our third set that we're going to test is CA over, let's see, FD. Okay, so that's going to give us 16/12, which is going to be 4/3. So if we look at this objectively, we have proportional sides and we also have congruent angles. So triangle ABC is similar to triangle DEF, and what we would say is triangle ABC, use the similarity sign, triangle DEF. The similarity ratio would be 4:3. Okay, so that's what you do. You test the angles, you test the sides, you write the similarity statement and the similarity ratio. Okay, so why don't you go ahead and start this one, and I'll actually leave this up, this example up, so that you can see it, and you're going to test the sides, test the angles, and see if it's proportional. Okay guys, thanks for watching. We'll see you next time.